Hello, in this podcast we're going to talk about forces, motion, and Newton's first law. First we're going to take a look at how forces cause different types of motion, and then we're going to look at the quantity known as inertia and Newton's first law of motion. Let's get started. How do forces cause motion? There's two general classifications of forces. We have balanced forces, and these are two forces of equal strength but acting in the opposite direction. So notice on this box we have a 5 Newton force. Newtons is just the way that we measure the strength of the force. We have a 5 Newton force pulling to the right, and we have a 5 Newton force pulling to the left. In this case, the forces are balanced. They're equal to each other and opposite in direction. We have unbalanced forces, and those are two forces of unequal strength acting on an object. They may or may not be in the exact opposite directions. In this case they are, but they don't have to be. So we have a 10 Newton force pulling to the right, and we have a 5 Newton force pulling to the left. They're unequal in strength, so these are unbalanced forces. And this is important because this tells us the type of motion. Forces cause objects to move. It's one of the most important concepts to remember in this course. Balanced forces cause no motion or constant velocity motion. So if this box were sitting on the floor not moving, and we applied a 5 Newton force to the left and a 5 Newton force to the right, it would be motionless. It was at rest, it'll stay at rest. However, if the box was already moving along the floor, let's say at 2 meters per second, and we applied a 5 Newton force to the left and a 5 Newton force to the right, it would continue to keep moving at a constant velocity of 2 meters per second. So important to remember, balanced forces cause no motion or constant velocity motion. Unbalanced forces cause an object to speed up, slow down, or change direction. Don't worry too much about this last one. We're going to get to that in a unit later in the course. But if we look here at this box, if it's at rest and we all of a sudden start pulling on it to the right with 10 newtons and pull to the left with 5 newtons, the object is going to speed up to the right. And as long as the forces are unbalanced, with the stronger force being to the right, the object is going to keep speeding up until we either have a greater force going to the left, in which case it'll slow down, or if we have balanced forces, it'll maintain a constant velocity at whatever speed it was at when the forces became balanced. Let's talk about inertia and Newton's first law of motion. Inertia is a quantity that measures how resistant an object is to changing its motion. Mass is a good way to measure an object's inertia. So heavier objects, objects with more mass, have more inertia because it's harder to get them moving, and if they're moving, it's harder to stop them from moving. Lighter objects have less mass and they have less inertia because it's easier to get them moving, and if they're already moving, it's easier to stop them from moving. So let's take a look at which one has more inertia, the cart in figure A or the cart in figure B. Well, it's the cart in figure A because it has a total of 34 kilograms of mass, whereas figure B only has 12 kilograms of mass. And of course we know it'll take more effort, more force to get this cart moving, and if it's already moving, it'll take more effort to get it to stop. Let's move on and talk about Newton's first law of motion, which is also known as the law of inertia. So Newton's first law says an object at rest will stay at rest unless acted on by an external net force, and an object in motion will stay in motion unless acted on by an external net force. So for instance, the book that's sitting on your desk, we know that if you don't push it or something else doesn't push it or pull it, it's just going to stay there. That's what this first part means. It's going to stay there at rest unless acted on by an external net force. The last one here, or the second one, is a little harder to visualize, but if an object's moving, it will stay in motion unless acted on by a net external force. So for instance, if we take a ball and we let it roll down the floor, it will keep moving until an external net force acts on it. Now, the reason I say this is hard to visualize is we know if we roll the ball, we know if we let it roll long enough, it's going to come to a stop. But that's because there's friction. So friction is that external force acting to slow it down. If we didn't have friction, we know that the ball would roll further. And in outer space, there is no friction. So things in motion in outer space just keep moving unless there's an outside force acting on it. Well, this ends our lesson on how forces cause motion and Newton's first law. I hope this helped and have a good day.